This is 2A, the part of the assignment where we have to make the lights turn on. We start that with an if statement in structured text with a check if the pulse button is being pressed, meaning true. Then the ton timer will be activated. Ton timer 1 will be set to true, and ton timer is set to 1 second. Here you can see. If not, then the ton timer is off. That is a check. That's the end if of the first if statement. The second if statement is if the ton timer is completed, the Q stands for completed, then the red light will be set to false, meaning it will turn on because the lights are reversed. And if not, if the ton timer is not completed, then red light will remain true. And here we can see that in action. The pulse button will be pressed, and after 1 second, the red light will turn on until I release it. This is assignment 2B in structured text, where we had to make the light blink after 1 second of holding the pulse button. So that's why the first if statement is to check if the pulse button is being held, which will be false when it is not, and turn to true when it is. Then, when this is true, the first ton timer will be set to true, which lets it walk, and it's a ton timer of 1 second. If the first ton timer of 1 second is completed with this little Q, which means that it's completed, will turn true. Then the GVL red will be set to false, turning it on, and the second ton timer will be set to walk, which will be 500 milliseconds long. When the second ton timer is true, completed, after 500 milliseconds, the red light will be set to true again, turning it off, and the third ton timer will be activated of 500 milliseconds again. Then, after this 500 milliseconds is ended, everything will be set to false again to turn every timer off. Then, if the pulse button is not pressed, just to be sure, everything is set to false again, so nothing keeps walking and ends everything. And then returns to the end after the program is completed. Stop. Here we can see it in action. When the pulse button is pressed, after 1 second, the light starts blinking. How to see this in action when we press the pulse button for 1 second, as I'm about to do now. The light will start blinking. In 2C, we have to make the light blink 10 times, after which it will stop blinking, even when we hold the pulse button. So, the first check is when the pulse button is being held, sending it through into the ton timer, activating the ton timer for 400 milliseconds, which will be sent to the next ton timer for 400 milliseconds. And that ton timer then will activate, if we scroll over a bit, the red LED. The red LED will shortly blink, after which it will activate a third ton timer again for 400 milliseconds, which will turn on the red LED. This will turn it off by putting it to true. This will turn it on by setting it to false. Then, if we go to the next line, we see here a CTU. A CTU is a counter. Here is the PV input is 10, which will be counting until 10 until it sends the signal to the right, and it will add 1 to the counter every time the red LED is activated, set to true, which is after the second ton timer here. So once every cycle. Once it has been reached 10, it will send to the pulse here, and then the pulse, the negated pulse will then turn off the red LED even when the pulse is still being pressed. So the LED will be turned off. Here we will see it in action. While holding the pulse button, it will blink 10 times, after it will stop blinking even when held. In assignment 2D, we will count the amount of times the start button is pressed as long as the switch is turned on. So here we have contact with the start button. send to a contact for the switch, checking if the switch is turned on or off. If it is turned on, then it goes to an add function, adding 1 every time the GVL is the start button is pressed to the old number. So having more and more, and this will be sent out to current counter value, also using current counter value +1 every time this is activated, so adding more and more. Then when the switch is activated again, we want to reset the current counter value back to 0. So we did that by having a subtract function here, subtracting the current counter value from the current counter value, of course creating 0 again. We can see that in action over here. By turning on the switch and then pressing the start button, you can see the counter going up, and resetting the counter again by flipping the switch back. And when the switch is flipped back, you can see that it does not add up